Hey guys, we cover today chapter 6 from our book on statistics, and it's going to be an easy exam if you understand the concept. So make sure that you read the chapter and the definitions carefully. And without further ado, let's start with the first one about the z-score. So the definition of the z-score is the number of standard deviations above or below the mean. So it's basically A. So if you remember, we have a normal distribution, and this will be the mean. We call the mean mu, and you have one standard deviation, two standard deviations, three standard deviations. So here z will be 1, this is z0, this is z2, this is z3, and here z will be negative. Also, you have a table in your book that shows, for example, the z-score and the percentile. So for a z-score of 0, you are at the 50th percentile, which means you're exactly at the mean. Z is 0. You move one standard deviation, z will be equal to 1. You move two standard deviations, and if you move -1 standard deviations, this will be your percentile, and basically z is equal to -1. So that was the first definition. Second one, find the standard deviation of the following numbers by hand and show work to earn credit. 4, 8, 9, 11, 13. So let me take this here. I'll erase the whole thing and start from scratch. I will need to use this formula from the book about how to find the standard deviation. It's from section 6.1. That's my formula. Sigma is the standard deviation. So I need to find mu first, and then find the deviation and the deviation squared. There's a table that we did. This is the table that shows. This is the table that shows the process, that shows how to do it. So 4, 8, 9, 11, 13. 4, 8, 9, 11, 13. This is my x's. These are the points. So start by calculating the mean. Mu is equal to 4 plus 8 plus 9 plus 11 plus 13 divided by the number of points, which is 5. So 4 plus 8 is 12. 9 plus 11 is 20. And the 13 divided by 5. This becomes 45 divided by 5, which is 9. So this is my x, and now I have to calculate x minus mu, x minus the mean. So 4 minus 9, which is -5. 8 minus 9 is -1. 9 minus 9 is 0. So this point is exactly at the average. If it was a grade, this student got exactly the same grade as the average of the class. 11 minus 9 is 2. 13 minus 9 is 4. Okay. So now my next step is to calculate the square of this. Sorry. X minus mu squared. So 5 squared is 25. 1 squared is 1. 0 squared is 0. 2 squared is 4. 4 squared is 16. Now I should add all of them. So 25 plus 1 plus 0 plus 4 plus 16. This is 20. And that's 26. So the answer is 46. So notice how the formula looks like. So I did sum them. I did calculate the difference, and then I squared them, and then I calculated the sum of the squared. Now I should divide by n. So divide by n, and this becomes 46 divided by 5. 46 divided by 5, it's 9.2. So it's 9.2. Now what I need to do, I need to calculate the square of this quantity. So 9.2 square of this quantity is 3.03. 3.03. So that's my answer. Showing all the work, that's my standard deviation. So if I want to just visualize how these points look like, I have 4, 8, 9, 11, 13. So imagine you have a scale, and you have 4, and you have 8, and you have 9, you have 11, you have 13. The average was 9, so that was the average. And the 3.03 gives me an indication of how the points are spread around the average or the mean. Okay, moving on. So give the 5-number summary for the following house prices. So I have these house prices, and I have to get the 5-number summary, meaning the minimum, the maximum, the median, the first quartile, and the third quartile. If you want to know how the 5-number summary looks like, it's gonna look like this box plot. And here's more details of how. So you need to find the minimum, the maximum, the median, and then the median of the first half and the median of the second half. Okay, so what we can do, we can open a new file, or erase actually everything. Okay, so my numbers, I should list them in order. That's the first step in getting this summary. So the minimum one I have is 65, and then I have two 51s. So 51, 51, 51, 51, 65. I have 80. I have 100. I have 120. Then I have 160, 180. Whoa, 180. I have 200, and I have what I call an outlier, which is a way up there. So a total of 10 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my minimum, that's my maximum. So I can start easily and say the maximum is 510, the minimum is 51. Now there's a median. The median is simply the number in the middle. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between number 5, and since I have 10 numbers, basically it's an even number, so there is no median. I have to get the average between the numbers in the middle. So you have these two numbers. See, you have 4 above, 4 below. So the median is somewhere in between, which is basically the average. The median will be 110, because it's 120 plus 100 divided by 2. So the median is 110. Now, so since this is the median, I have this median divides the set into two sets, the upper half and the lower half. So this will be the median of the upper set. So the 180 is the median of the upper set, and we call this the third quartile. And then 65, which is here, will be the first quartile. So this is basically my 5-number summary. I can also draw it like this. This is the max, this is the min, this is the median, this is third quartile, and this is the first quartile. We'll move on. So this is telling me, now move on to number 4. The lengths of a particular species of insects are normally distributed. So normally distributed meaning that it will be like this. Okay. With a mean of 4 millimeters and a standard deviation of 0.2 millimeter. Interesting. So we have the mean, so the average of all species length is 4 millimeter. Standard deviation of 0.2 millimeter. So most of them are concentrated in the first, around the mean. So it's 0.2 millimeters. Well, this means that the first range plus or minus the range that has mean plus or minus 1 standard deviation will have 4 minus 0.2 and 4 plus 0.2. We have 3.8 millimeters, 4.2 millimeters. Okay. And the 68% rule is telling me that this range basically encompasses 68% of the data. Okay? So most of the data is concentrated here. So the first statement is that it's very simple. 68% of the data has length between 3.8 millimeters to 4.2 millimeters. Okay. Now the other statement, statement 2. 95% exist between 95% of data exist between 2 standard deviations, between 3.6 millimeters and 4.4 millimeters of the data. Statement 3, 99.7% exist between the mean minus 3 sigma and the mean plus 3 sigma, meaning they exist between 4 minus 0.2 times 3, meaning 4 minus 0.6, meaning 3.4 millimeters. That's the minimum. And the maximum is mu plus 3 sigma, meaning 4 plus 0.6, meaning 4.6. How do I confirm this? Here's your Here's your formula or the figure from the book that shows the three formulas. 68% of the data exists between plus or minus 1 standard deviation. So in our problem, the mean was 4, the standard deviation was 0.2 millimeters. So the range for my data was between 4.2 and 3.8. The second one, it's 2 standard deviations, so between 0.4 to minus 0.4. For the third one, it's 4 plus 0.6 and minus 0.6, which means for the second one is 4.4 to 3.6. Here for 3.4 to 4.6. Okay, so this is the formula that we used to write 3 equations or 3 facts about the length of this species. I know it's not very neat, but I hope that you guys got it. Okay, number 5. The sum quartile is the median of the upper half of the numbers in a list. Median of the upper half of the numbers in a list. So remember, we have 5 number summary. We have median here, and we have the max here, and this is the upper half. So the median, this is the upper half. So the median of the upper half, we call this the third quartile. So the answer is C, the third quartile. And if you want to check that from your book, go to figure 6.1. So this is the median, this is the maximum, and the median of the third of the upper half, we call it the third quartile. So that's kind of a verification of what we mentioned. Okay, which of the following is included in the 5 number summary? Again, the median, fix A. Not the mean. The mean is the average. We don't include it in the 5 number summary. Okay, so we have Michael's 5 test scores were 75, 67, 88, 91, and 84. What is the mean test score? Now don't confuse the mean with the median. The mean is the average. The mean, you would get it by simply summing the numbers and dividing them by 5. Mean is equal to 84 plus 81. Oops, messed up. 75 plus 67 plus 88 plus 91 plus 84 divided by 5. So, in my calculator here, $75, 67 plus 88, 84, 91. Four or 5 divided by 5, and the answer is 81. Okay, so that's our answer. Now, the following question is interesting. Gives us the same numbers and asks about the median of the test score. So in order to get the median, you will need to sort these numbers in order. So you have 67 as the minimum one, and then you have 75, and you have 84, you have 88, you have 91. That's the minimum, that's the maximum, that's the number in the middle. This is your median. Suppose that every student in your class scored 75% on their test. What's the standard deviation of the exam scores? Before you panic and say, oh, I don't have more ideas, think, what does the standard deviation represent? So let's say I have 5 students. Student 1 got 75. Student 2, again 75, because all of them scored 75. 75, 75, 75. What's the average of this class? 75. You can, if you don't believe me, add them up. Divide by 5 and see how the average is 75. What will be the standard deviation? It will be 0. Why? Because the standard deviation measures the spread around the average. And guess what? All of these students scored exactly the same thing. So the answer is 75. Number 10. An auto dealer's sales numbers are shown in the table below. Find the mode price for the car sold in August. So what's the mode? Mode meaning the most repeated. Mode is all about repetition. So we're talking about the month of August, and we want to know which one was repeated the most. It's a little bit confusing here because you have the numbers here. So you sold 24 cars that cost $25,000, 37 cars that cost $20,000, and you sold 44 that cost $15,000. So the mode of your prices is basically the number corresponding to the maximum amount of cars sold. So this is your answer. Moving on. Find the certain number for a certain number of vehicles, their mileage is recorded and summarized using a box plot. Which of the following is not correct? Now, so this is the minimum. Before I look at the answer, let me make sure I understand this. This is my minimum. It's about 17 probably. Let's see, it's probably 17. The maximum is about maybe 38 or 37. This is the median. Median is about 22.5. This is the third quartile is about maybe 28. First quartile is about maybe 21. So the mean is around 22.5. Now this, you may think this is true with only one condition. This is the median, not the mean. So this is the trick. So this is my answer. This is wrong. But to verify, let me make sure that the others are correct. The difference between the maximum and the minimum is about 20. That's very true because actually it's actually correct. This is 17 or 8, and probably this is 37. So it seems to be right. This is about 20. So that's correct. The spread from the first quartile to the third quartile is about 8. The spread is the difference. This is the spread. So between 20 and 8 or 20, yeah, 21 and 8, that's like 7 or 8. So that makes sense. So the median is closer to the first quartile than the third quartile. This is the median. Haha, that's the median, not the mean. It's closer to Q1, to the first quartile, because this distance is smaller than this distance. Now this is also true. And we verified that this is wrong. This should be the median, not the mean. Moving on. If the data are normally distributed, which of the following is not true? It's gonna be bell-shaped, that's true. Mean and median are the same, that's true. Most of the data tend to be clustered relatively far from the mean, that's not true, because usually if normal distribution, the data will be close to the mean. Okay, moving on, almost done. A 6-year study, certainly in a certain country, found that the birth weights of newborns were normally distributed, with a mean of 3758 grams and a standard deviation of 496 grams. What's the z-score for a newborn weighing 4,000 grams? So this guy, basically we're trying to see how far is this guy from the mean. So the z-score formula is simple and cool formula. This is your this is a problem about the z-score formula. So it's basically the data point. In this case, it's 4,000 minus the mean divided by standard deviation. So what was my mean? 3758. Divided by my standard deviation in the problem, which was 496. So the answer, if I do the math, will be 0.49. So that's my answer, 0.49. Number 14. The IQ test scores are normally distributed and are scaled to a mean of 100 and a standard deviation of 15. If someone has a z-score of 1.8, what's the IQ score? So you have mean of 100, standard deviation of 15, and you have the data point, which is 1.8. Actually, so this means that this guy's score, so this is the mean, 100. This is one standard deviation, which is equivalent to 15. If the guy, so the guy is this, the guy is not 2 standard deviations from the mean, he is 1.8 standard deviations from the mean. So it's almost here. So he's gonna be standard deviation times 1.5. Sorry, 1.8. So this is equal to 15 multiplied by 1.8, and that's equal to 27. So the distance between the guy and the mean is 27. So the answer is 127. If you don't like drawing the curve and seeing how the data look like, you can always refer to this formula. The data point is equal to the mean plus z-score multiplied by standard deviation. So your mean is 100 and z-score was 1.8, and your standard deviation was 15. So this will give you 100 plus 27, 127, which is the data point. So we use the formula to get the same answer. Finally, for data points above the mean, the z-score is positive, negative, or 0. We said many times before that this is your mean, and here on the mean the z-score will be 0, and here the z-score will be positive, and here the z-score will be negative. So the answer is 15A, the z-score will be positive. I hope that you guys benefited from this review, and feel free to ask any questions. Good luck. Bye-bye.